Okay, so the proof of de Moivre using induction. All right, this came up on the exam paper a couple of years ago, and it appeared like this. So cos theta plus I sine theta to the power of n is equal to cos n theta plus I sine n theta. So when you're raising cis to a power, you can multiply that power in by the two angles. Now, de Moivre in the log tables and de Moivre as you have used it has an or in front of it, has the modulus in front. So when you're raising something, when you're raising a complex number to a power like this, yes, you can multiply the n in by the angle, but you still raise the modulus to the power. So you still get the or to the n, it's just the angles that you multiply by n. I think you could be asked to prove it like that with the modulus. I'm going to prove it as it was asked on the exam paper a couple of years ago without the modulus, but I will either do a video with the modulus or a link to another video where it's done with the modulus. The proof is really no different. There's just a little bit more writing to it because you have to deal with the modulus as well. All right, but as I said, I'm going to prove it as it is here, asked in the exam papers a couple of years ago. So, prove using induction that, as I said, it's just de Moivre. All right, so it's using induction, so it's the same three steps we always use. Step 1, show P1 is true. So that's subbing 1 in for n, so that would be cos theta plus I sine theta to the power of 1 is equal to cos of, instead of n theta, 1 theta, or 1 multiplied by theta, plus I sine, and again, 1 theta. So anything raised to the power of 1 is itself, so on the left-hand side, that's just cos theta plus I sine theta, and over here, 1 times theta is just theta, so that's cos theta plus I sine theta. So same thing on both sides, correct. Therefore, P1 is true. Step 2, as ever, is assume PK is true. So that's cos theta plus I sine theta to the power of k is equal to, and subbing k in for n. So cos k theta plus I sine k theta. 3 then is to prove PK plus 1. Just to briefly stop there, when this came up a couple of years ago, like a lot of induction questions, it was worth 15 marks, and you got 7 marks out of 15 for getting that PK step right with the P1 step. All right, so if you got those 2 steps, which are very, very straightforward, there's 7 out of 15. You have passed the question and a little bit more. Okay, into the proof then. So k plus 1 in for n. So cos theta plus I sine theta to the power of k plus 1 is equal to k plus 1 in for n on this side as well. So this is cos, instead of n, it's k plus 1 theta. So it's the entire thing multiplied by theta. So the k plus 1 multiplied. But you could multiply it in now and write it as theta k plus theta, or we might do that later. We'll see how we go. Plus I sine, and again, instead of n, k plus 1 times theta. So what we are going to do here is work on the left hand side to make it equal to the right hand side. All right. I'm just going to write out the left hand side. I'm not going to write the equals this the whole time. It'll take a needlessly long time. So we're just going to work on this and hopefully get this. Okay, we might go back to the right hand side and maybe multiply this out if that is going to make it clearer to us. But for now, we'll just work on the left hand side, see if we can get this, and then maybe if it's not going well for us, we'll multiply this out and see if that makes it any clearer. But on the left hand side here, working away in this, to the power of k plus 1. So we've done this over and over again in induction, that when we get to the power of k plus 1 like that, we split it up. We use that rule of indices in reverse nearly, okay? That we write that as, so left hand side is going to be cos theta plus I sine theta to the power of k multiplied by cos theta plus I sine theta to the power of 1. All right. The reason we do that is we get cos theta plus I sine theta to the power of k, and that was the left hand side in what I assumed. So just like I do in a lot of induction questions, I'm going to sub the right hand side of the assumption in here. Okay, so I split this up so that I get my cis just to the power of k. That's what's on the left hand side in the assumption. That's equal to this, so I can sub it in. So cos k theta plus I sine k theta multiplied by, it's just cos theta plus I sine theta. So next step is just to multiply this out. So cos k theta by cos theta is just cos k theta cos theta. Okay, the angles are different, so you can't kind of do anything with those. It is just the product of the two of them when you multiply it together. Plus cos k theta by this is plus, you put the I out in front, plus I cos k theta sine theta, then plus I sine k theta cos theta, plus I sine k, there's I by I here, so that will be I squared sine k theta sine theta. Now, whenever we get I squared in a complex number question, we sub in -1. And in fact, when this came up a couple of years ago, they kind of gave you that little reminder in the question when they were asking to prove it. So I'm just going to rewrite this out again, but with -1 in here instead of I squared. So this part is real. You're going to sub -1 in there, so that part is real. That's got an I in front and that's got an I in front. So they're both imaginary parts. So I'm going to do two things in one here. I'm going to sub -1 in for here, and then I'm going to move it so that I've got my real parts together and my imaginary parts together. So this is equal to cos of k theta cos theta -1, so just minus sine k theta sine theta, plus, and then of the I common to both of these, so I'm just going to factorize the I out, plus I on cos k theta sine theta plus sine k theta cos theta. So real part, imaginary part. I want it to look like this, remember? So that's the right hand side I'm aiming for. So I need to make this real part look like this, and I need to make this imaginary part look like this. So maybe if I left you on that for a couple minutes, you might kind of hit on this, or this idea might crop up. It kind of looks like those trig identities that we would have done in trigonometry. So if we go back in our log tables to where these identities are, and if we look for something, I suppose you could look at what this looks like, but what I might do is just kind of go from this one here. So I've got cos of an angle by the cos of some other angle minus the sine of that first angle by the sine of the second angle. So cos by cos minus sine by sine. So like your k theta is like A here, and your just theta is like B. And what's that? That's cos of A plus B. So I can rewrite all of this. This looks like the right hand side of this. So I can rewrite that as the left hand side of that. So that's equal to the cos of A plus B. So the two angles added together. So that's k theta plus theta. And then this one over here, so plus I, and then cos of an angle by the sine of an angle plus sine of an angle by the cos of an angle. Now the order is a little different here, but if you take kind of theta to be A and k theta to be B here, sine A cos B plus sine B cos A, okay? It's this one, okay? The order's a little off, but it is this identity here. It's the right hand side of this. So I can rewrite this as the left hand side here. So that's I sine, and it's the angles added together again. So k theta plus theta. So there's my left hand side. There's my right hand side. So look, you could multiply the right hand side out here and it would look like this. Or else, seeing as we're working on the left hand side, you've got theta common to these two terms within that angle. So kind of factorize the theta out and it will look like this. So that's equal to the cos of factorizing theta out within this angle leaves me with k plus 1 plus I plus I sine, and then factorize the theta out there as well. So theta on k plus 1. Okay, and the order is different in the multiplication, but that is equal to the right hand side. Therefore, you can either write this out again for all n is an element of n. You've been using P1, Pk, Pn, so you can just use your kind of Pn notation. Therefore, Pn is true for all. And it's all natural numbers. It's starting at 1 here. There's no restriction on it like there might have been in some other proofs or some other induction proofs. All right, as I said, instead of Pn there, you could write this bit of the answer out, okay? But there's your proof of de Moivre. As I say, you can be asked to do it as it appears in the log tables. So that would be with an or there, and then in front here the or to the n. Okay, so a question could appear like that. The proof is the same, there's just a bit more writing out and stuff like that. As I said, I'll either do that now or I will I think I'll maybe link to another video doing that, but there's your proof of de Moivre.